Welcome back to Robotic Mechatronics System Design course. On this lecture, we will discuss control valves in pneumatic systems. Today's topics are as follow: control valves and lots of examples, simulation and pneumatic circuits. So get yourself ready to work in Festofloyd scene and work on examples and homeworks as we are proceeding forward. Control valves. So far we have talked about directional valves that they will take care the direction of the flow path in pneumatic circuits, but there are some different category of valves which they take care of the flow. They control the basically flow rate, they control the timing of flow, and so on and so forth. So we will go through these type of valves in this lecture. The first one is a non-return valve, allows a medium to flow in only one direction. Okay, so this one is a free one. So in this one, the air in the pipe could flow from this direction, okay, from down to top, but cannot flow from top to down because of this, let's say, small ball here. And this small ball will block the pathway. Another type is spring-loaded. So on spring-loaded, the air again is allowed to flow from let's say down to top, but once the airflow stops, then the spring will bring back that ball to its initial position. Okay, we have pilot signal closes the valve. So on this one, the solid line shows the main air pathway, and the dotted line shows the control or pilot signal line or signal line. So we need to send the signal by air pressure, by airflow to the valve, and then make it active. So what happens when we send the signal? It will closes the valve. So it will basically stop the ball from moving, and the air cannot flow from any way. Once we stop sending the air through the signal line, then the valve works as the normal one. Another one is the pilot signal opens the valve. On this one, very similar to the previous one. However, when we send the signal, when we open the air flow, let's say on this line, then it will force the ball to be open. So basically the valve will act like a normal pipe, and the air could flow from any way, top to down and down to top. And once we stop sending the signal, then the ball will back to its place, and the valve works as a normal non-return valve. Another one is a non-return valve with restriction. On this one, we have two parallel pathway. On one of the pathway, we have a normal free or spring-loaded non-return valve, and on the other pathway we have this throat here that limits the air pathway. So on this one, this throat here acts like a resistance. So analogy to this circuit is just a parallel a resistance in electrical circuit. So once the air uh, flows from, let's say, left to right, so it cannot go through this way because the ball will block the pathway, and it has to go through this throat. Once the air flows from right to left, since we have a resistance here, the majority, or the basically a big portion of the airflow will go through the non-return valve because the pathway is free, or is just like a short circuit here. Okay, so on the non-return valve, we have a symbol, and this is the spring-loaded one. And here we have a schematic diagram, or the cross section of these valves. So you see that we have this plug that could close the pathway completely. Once the air flow from right to left, it will push this plug away, and the air could flow freely. Once the air wants to flow backward from, let's say, left to right, then the air itself and the spring both will close the pathway, and it will block the pathway. Throat valve could be a separate valves. On this one is basically nothing like a valve that closes the orifice, or we have an orifice here that we could change the opening of the orifice. You see the symbol here. Basically, it shows that we have a narrow pathway, and it could be a variable one because we have a knob. We have this screw knob that we could open and close the pathway. And you see one industrial sample of these type of valves, and you see the symbol on them. So always on pneumatic systems and parts, we always look at the symbol on the parts to understand what is the part and what is the functionality of the part, how we could install it, and so on and so forth. A one-way flow control valve, we already discussed it, how it works, but here we have industrial sample. You see the symbol on that, plus here the cross-sectional area shows how it works. So on this one, when the air flows from left to right, it will here, you see that we have some let's say plugs, and the air itself will close this plug, so air cannot flow through these pathway, and it has to go through the throat valve. Okay, so similar to the symbol, if the air flows from left to right, it has to go through the throat valve. Once the air wants to flow from right to left, then it could push back these plugs here, or these obstacles, and the air could flow freely without any restrictions, and it doesn't need to go through the throat valve. Okay, so now we want to see how we could use these one-way flow control valves. They are very common. Most of the air cylinders comes with one of these one-way airflow valve. They are either embedded into the cylinder, or it's very common to install them separately, and see how we could basically install it. So I strongly recommend you to open one of your directional valve examples and the homeworks that you had before and try to put the one-way control valve. Okay, so we could place the flow control valves in 4 different combinations on the way of double acting cylinders ports. So you see that 4 different combinations, one on this pathway, the other one on this pathway. So we could have 2, but the combination could be this one, this one, this one, and this one. So we have 4 different combinations. Let's see which one is the best one. Which configuration could achieve highest possible power with different speed of forward and backward motion? So what is the main reason to install them? To control the speed. You want to control the speed of the cylinder. Okay. However, we want to have a full power. So what does that mean? So this is the answer. This is the best combination, and we should have this combination installed. Let's say why and what is the reason. Okay, so when we have this one and this pathway, when the cylinder or the piston, let's say, wants to move forward, they have full power. Why? Because the air could freely flow through this non-return valve here. So the air is not restricted. We have a full pressure here on this chamber. However, the air here on the low pressure chamber wants to be exhausted, yes, and it has to go through this valve, but it will go through the throat. That will reduce the speed of the piston. Okay, so we have a full power, we have a full pressure and the maximum force here, so we could still move the maximum possible load with the air pressure of the compressor, but on the other side we have limited speed, and sometimes we don't want these pistons to move that fast freely, and the speed should be adjusted based on the application and the safety. And once the piston wants to move backward, then again we have a full power on this chamber, which is the high pressure one. Why? Because the air could flow freely through this non-return valve and doesn't need to go through the throat valve, and the low pressure chamber air that should be exhausted will have to go through the throat. So this is the best combination. I strongly recommend you to open one of your example homeworks and install these one-way flow control valves and check different combinations, change the throat opening, double click on them, change the throat opening, and see how does it affect the speed of the piston. Okay, so now we want to discuss the pilot check valve. On the pilot check valve, we have these symbols: the pilot check valve that closes the valve, and the pilot check valve or pilot signal that opens the valve. Okay, so one closes the valve, the other one opens the valve. On this one, we have this schematic diagram and see how it works. Okay, so here we have a pilot pressure. So this is this dotted line here. Okay, it's separate. It is separate from the main airline. This is the main airline here. Okay, so once, let's say this chamber is pressurized, once the signal is sent to the valve, then this piston will move upward. Okay, so now what happens, it will move upward, and it will open this opening here. Okay, so we have this one, this type basically. We have this type. Now the air could flow freely from both ways. Okay, once the signal is stopped or this line is closed, the piston here, this small piston, will be retreated back, and now this obstacle will work as a non-return valve, or as this ball here in the symbol. If the air, in this case, when we stop sending this signal or sending air here, then when the air flow from this way, we have a free flow because it will push back this obstacle here. Once the air flows from this way, the air itself will close this opening, will basically bring back this obstacle to its place, and the flow will be blocked. Okay, so this is how it works on the pilot control valves. When we say we have a pilot valve, it means that we have a separate pathway and for the air, and that pathway is solely used for sending signal to either activate the valve or open the valve or close the valve. It depends on the application of the valve. We have one pneumatic circuit here. We will discuss it more as we go forward, and we will simulate it. And this is for the elevator in the testing station of MPS 500. On this one, we have two non-return valve. However, they are the pilot one. You see that this is a main line, one port and two ports are for the main line. 2-1 ports are for the pilot lines. So pilot lines will send the signal to these non-return valves, and they will open it and close them. And the reason we have these non-return valves for the elevator, because the elevator has to lift weight, and plus it needs to compensate its weight itself. So we need to be careful of the air pass flow, because when we lift a heavy weight, or once the elevator weight is high enough, it could push back the elevator back to its initial position, or it could create some vibrations. So we need to have these specific valves and send the signal and close the pathway, and be sure that the weight of the elevator or the weight of the load does not affect the functionality and the direction of movement in the elevator. We will discuss it more as we will do the simulation and the circuit. Okay, now let's go through the example 5. Okay, it is an example. I'm gonna explain you, but expect you to have that FestoFloyd sim open and do the simulation. You could make this circuit on top of the previous examples and homeworks that you already made in the FestoFloyd sim. We want to have an indirect control of double acting cylinder. For the low speed, we want to have a low speed, on forward motion and a high speed on backward motion. You see that we have a new requirement here that we didn't have it in the directional valve lecture. The positive control signal is automatic and negative control signal is automatic. You already made this part of the circuit in previous homeworks. We will add this new feature to our circuit. Okay, this is the solution of example 5, and we have the indirect control. We have these two control valves or secondary valves, and this is our check valve here. You see that we are satisfying our requirements in the example. So let's see what happens here. For the forward motion, we don't have, this is a forward motion when we pressurize this line here. We don't have any restriction on this line here. However, we have this check valve here, and the air has to go through the throat. So we could limit the forward motion. However, for the backward motion, you see that the air will pass through the non-return valve here. There is no any restriction on this pathway, so the cylinder will move with the highest possible speed. The next control valve is shuttle valve or OR valve. So these are logical valves. Some of them could be replaced with the PLC programming. However, they are still in use in industries, and if we understand how they work, then we could better, let's say, work or program or PLC. Okay, so this is the shuttle valve or OR valve. So this valve, you see how it works. You have X port and Y port and A port. Once the air flows from Y port, then this pole here will block the X port and the A port will be active. If the air flows from the X port and let's say the Y port is not pressurized, then the A port is pressurized. So either X or Y port could activate the A port. If we pressurize both the X and Y port, still the A port will be pressurized, okay? So that's why we call it OR port, because either X or Y could activate the A port. This is the symbol here you see is very similar to the schematic diagram here. We have this pole here and pathways and X and Y and A port, and this is one industrial sample of these type of valves. Okay, so on this homework, okay, I call it homework, I will go through the solution, but I will expect you to do the simulation and submit it on Moodle. On this homework, we want to have a direct control of single acting cylinder, positive control signal, manual from 2 points or 2 valves. Okay, so the reason for this could be because we want to activate this cylinder from 2 points in the factory, or we want to have a safety. For example, both the left and right hand of the operator should be on the thumb bottom or should be on the pedal to activate the cylinder. Negative control signal, releasing the manual valve. So you see that this is the new requirement that we want to satisfy with the shuttle valve or OR valve. Okay, so this is the solution in Fistoflow SIEM, and you see that now we could control this single acting cylinder from 2 valves. Both of them are main valve. None of them are let's say secondary or control valves. Both of them are main valves. However, we have this OR valve here, so either this one or this one could activate the cylinder. Okay, sorry, I said that this type of valve could be used for the safety. That's for the AND valve, not for the OR valve. because for the AND valve, we want to have both of the valves active at the same time, not the OR valve. OR valve cannot give us safety, but OR valves could be used to operate the cylinder from two points in the factory or the machine. Homework 10, you want to have a direct control of single acting cylinder. Positive control signal manual from 4 points or 4 valves, and negative control signal releasing manual valves. So very similar to the previous one. However, on this one we want to have 4 valves that each of them or either of them could control the cylinder. Please, once you are going through this homework, please stop the video or stop on the on this page if you are reading through the PDF, and try to come up with the solution yourself, because it's a very good practice and rehearsal to understand and design these pneumatic circuits, and it will help you to solve more advanced complicated problems by your own. Okay, so we have a solution here. We have 4 valves as it was required, and you see that we are using 3 OR valves. Either of these valves could activate this single acting cylinder, or combination of them could be activated, but anyway the cylinder will be activated. So one of them is sufficient to activate the cylinder. The next type of control valves are 2 pressure valve or AND valve. So again, this is a logical valve. As you could see, when the X port here, when the X port is activated and the Y port is activated, then this obstacle will stay at the middle, and the pathway will be open to the A port. If just one of the ports are activated or pressurized, then and the pathway will be blocked, and we won't have high pressure at the output port. This is a pneumatic symbol, very similar to this schematic diagram here. As you could see, we have this spool or obstacle that moves left to right, and we need to have a pressure on both X and Y to have output pressure at the port A. On this example, we want to have indirect control of double acting cylinder. The speed could be adjustable for forward and backward motion. Okay, so this bullet point requirement, we had it previously on previous homeworks and examples. On the positive control signal, we want it to be manual from 2 points at the same time. Okay, this is a difference from those examples and homeworks in shuttle valve section, or by pedal from the 3rd point if the rod is retracted. Okay, so we also have this OR condition here, and the negative control signal needs to be automatic. So it's clear that we need to have at least one AND and one OR valve to design a circuit which satisfies requirement of this example. This is one possible solution for this example. You see that we have this manual activation valve here by pedal, Okay, so when we activate this valve, it could activate the system, and the system will start to work automatically back and forth, because we have these two secondary valves and we have sensor feedbacks on them. Okay, what is the alternative to this manual one? These two valves, so yeah, these two valves or these two push buttons should be pressed at the same time, because we have this AND valve here, and when we press both of them at the same time, it will activate the system, and the system will start working and going back and forth automatically. So you see that we are using these check valves here to control the speed, and in many of the examples and the homeworks, it will be a common practice to have these check valves on any pneumatic actuators. Example 7, we need to have indirect control of double acting cylinder. Speed could be adjustable for forward and backward motion. Okay, so far we had these requirements before. Positive control signal manual from 2 points at the same time, or by pedal from third point if the rod is retracted, similar to the previous one. Negative control signal by pedal if the rod is extended. Okay, it's very similar to the previous example. Hope you guys could come up with the circuit yourself, but as it is example, we will go through the solution, but I expect you to for yourself, for learning purposes, to design the circuit in Festo Sim and simulate it. Okay, this is one possible solution for this example. And you see that this part is similar to the previous example. We could activate the system either by this pedal, or by pressing these two push button, and we could stop it, or we could have a negative control signal by this pedal valve. Homework 11, indirect control of double acting cylinder. Speed could be adjustable for forward and backward motion. So it means that we need to have two check valves, positive control signal, manual from 2 points at the same time, and negative control signal should be automatic. This is a simplified version of previous example, but as this is homework, you need to keep the solution and submit it to Moodle. I will go through the solution quick. This is a solution for this homework. This is basically for the forward motion or the positive signal, we need to activate both of these valves or press these two push buttons at the same time because of the AND valve here. And the negative control signal is automatic. Okay, so forward is manual, backward is automatic. That's why we only have one sensor, or one sensor is only used. Plus we have adjustable speed on the cylinder. Homework 12, indirect control of double acting cylinder. Speed could be adjustable for forward and backward motion. similar to the previous one. Positive control signal manual from 2 points at the same time if the rod is fully retracted, and negative control signal by pedal if the rod is fully extended. Again, this is a simplified version of previous examples. I will go through the solution quick, but I expect you to submit it on Moodle. So you see that this is a activation of the system by by pressing two push buttons at the same time, and this is a pedal valve for the negative control signal. Quick exhaust valve is another type of control valves, and on these valves is very similar to OR valve or shuttle valve. However, one port is for exhausting air. This is a muffler basically symbol to the atmosphere. Okay, so see how it works. When the one port is pressurized, then this ball or obstacle will close the passway of the port 3, and the air has to go through this port 2. However, when the air wants to be exhausted from a chamber of a cylinder through the port 2, then the obstacle will block the passway to port A, and the air will be exhausted to the atmosphere. So why we have this dotted line here in the symbol? As we said, these dotted lines are used for signal lines. That means that the valve itself is adjusting or controlling itself. So the passway of the air inside the valve will change the status of the port 3, and that's why we have this let's say close dotted line. It means that the internal airflow will change the status of the control valve. We will have different type of control valves with these type of, let's say, symbols. If this, let's say, signal or dotted line is an open one, it means that this is a pilot valve, and this is a one separate signal valve that should be pressurized by a separate line. However, when we have the closed line, it means that we don't have a separate pilot port, but the airflow pass inside the valve will change the status of the valve. Okay, so let's see what is the application of these type of valves. This is one industrial example of these valves. And here we have one application. So we want to have a slow in the forward direction and fast on the backward direction. I could say very fast or the maximum possible speed. So for the forward direction, the air will go through the port 4 of the main directional valve to the port 1 of the quick exhaust valve, and when the port 1 is pressurized, the port 3 will be closed, and the port 3 will be active and pressurized, and the cylinder will move forward normally. However, since we have this check valve here, the speed of the forward motion is limited or controlled by this check valve. What about for the backward motion? For the backward motion, This check valve does not have any effect on the airflow. We'll have the highest possible pressure here. However, the air in this chamber should be exhausted. Normally, the air will be exhausted through the directional valve to the atmosphere. But when we have these quick exhaust valves, air doesn't need to go all the way to the directional valve, and we will have a shortcut to the atmosphere. So the air will come here and we'll push this ball to the left. So we will close the port 1 and the air will be exhausted quickly through this muffler to the atmosphere. So when we use this type of quick exhaust valve, we could achieve highest possible speed, and we could reduce the let's say friction lost in airline. Homework 13. In direct control of a double acting cylinder, speed could be adjustable for forward and backward motion, similar to the previous examples. Manual mode, okay, so we don't have automatic on the forward. We have two modes, one manual mode and the other one is automatic mode. On the manual mode, we want to have a forward and backward motions, both manual by start and stop button. Okay, and on the automatic mode, we want to have a forward and backward motion, both automatic. Okay. This is a solution for this homework 13. So you see that since we are two modes, we are using these OR valves. So we could switch between the manual mode and the automatic mode. Either of them could activate the system. So on the manual mode, we have this start and stop button. And once we press the start, then the cylinder will move forward, and once we press the stop, it will move backward. And in the automatic mode, these two secondary valves will be in charge of changing direction of the cylinder. However, how we could switch between modes, we could switch changing between modes with this valve here, and this valve will change the mode from manual to automatic. So on this exact position of this valve, we have the automatic one active. So the automatic one on this one is active now, and if we switch it, then the manual one will be active. Okay, three-stage directional valve. I will stop the video here. I think we had enough materials for this session because you have lots of examples and homeworks to do by yourself. So you need to spend more time going through this video. I'm going to stop it here and continue with the rest of control valves topic on a separate session and video.